Hi everyone, in this video we're going to talk about rational functions. So the question is, what is a rational function? Okay. So a rational function, or a function of the form f of x equals n of x over d of x, right? So if I have a function that looks like a fraction, basically, where d of x is not equal to 0 and nx and dx where nx and dx are polynomials, is called a rational function. So you can think about a rational function as a polynomial divided by a polynomial. Note that the denominator can never be, so it cannot be a zero polynomial. If it's a zero polynomial, then that function is not defined, right? So when we talk of rational functions, be careful about the domain of that function, because it cannot be all real numbers depending on when that becomes 0. All right. So what's our examples of rational function? So one example of a rational function can be the function 1 over x. That's a rational function. My numerator is a constant polynomial of 1. My denominator is a polynomial x. Another example of a rational function can be x squared plus 1 over 2x plus 3. That is also a rational function. Okay. If I said something like square root of 2x over e to the x, well, that is not a rational function, right? It's not a rational function because those are not polynomials. It's an exponential function, and that's a radical function. They're not polynomial functions. Okay, so as mentioned previously, we need to be careful about domains of rational functions, right? So how do we find the domain of a rational function? I need to know where this function is not defined, or where the function is defined for that matter. So take an example. We have a rational function that is fx equals x squared minus x over x squared minus 6x plus 8. So what is that domain of that rational function going to be? So what we do here is we look at this denominator, right? So our denominator here is that denominator for us is x squared minus 6x plus 8. Okay. Now, as I said previously, I mean, think about fractions, right? We cannot divide by 0. So my denominator can never be 0. So I need to figure out when this denominator is 0 and take those points and take them away from the real line, right? So I have this. I set it equal to 0. And if I factor this, I'm going to get x minus 4, x minus 2 equal to 0, which means at the points x equal to 2 and x equal to 4, right, this is where my denominator becomes 0. So the domain for this rational function is going to be all real numbers. So it's everything on the real line except for these 2 points. So I can write that as all real numbers except 2 and 4. But I also want to write this in an interval form. So how do I do that? Well, I'm going to go all real numbers to the left of 2 are fine. So I'm going to have negative infinity to 2. Everything between 2 and 4 is okay. So union 2 to 4. And then everything to the right of 4. So that's going to be 4 to infinity. Remember, the only thing that is skipped here is 2, right? Since I've opened parentheses, 2 is not included. Same way, since I've opened parentheses here, 4 is not included. So that's the same way of saying all real numbers except 2 and 4.